Hi there, welcome back to the channel and welcome to a new project. This time it is a stereo tube receiver. This is something I've been wanting to do for some time, and some of you have actually asked me when I was going to tackle a stereo tube receiver so that I can show some of the alignments. In fact, to be honest, I wanted to do it so that I could learn how to do some of the alignments. I've never aligned a stereo tube radio, so this is a special one for me. However, it took me a while to decide to buy this radio and to do the restoration, because it's actually quite ugly, and I couldn't figure out why. Because this is a Saba, and Sabas for me are the pinnacle of quality from that tube radio era. I love them. I've done a lot of them, but when I saw the photo of this thing, I thought, not quite my cup of tea. But then I realized, actually I've realized now, that this is not how this radio was sold originally. So there's some hope. But as far as Saba's concerned, I've always loved Sabas. They're always very complex, very interesting. And I've done quite a few. I've actually made a list because I've forgotten some of them. I've done the Freiburg 8, which sits here in my office. I've done two Meersburg W3s. I've done a Freiburg W2, which was a beautiful, beautiful radio. I've got a series on the channel on that restoration. I did the Breisgau 8 series, which was really a, solder and chat to really learn how this thing works. And I really enjoyed that one. I did a UW175Z, which was just AM, no FM. This was for a friend. And then I bought, at one time, bought a Villigen 12. And the Villigen 12, the reason I bought it is because it was from 1963, which is my birth year. And I wanted to have a Saba that's as old as me. It was, quite frankly, a little disappointing. And the reason is that Villigen was really the bottom end of the quality range for Saba. Now, bear in mind, the bottom end of the Saba quality range is probably still much, much higher than the top end of some other brands. But it was completely different to what I was used to with the other radios. In terms of complexity, in terms of engineering, it was rather stripped down. So it didn't really give me that much of a thrill to do that one. There was very little to do. I didn't even do a series on it. And I ended up selling that radio because somebody really wanted it. But if you don't know, the Sabas, especially from the 50s, used to come in various ranges. You had the top end, which was the Freiburg. The Freiburg model was always the most expensive one, the most complete one. It had the most complex automatic tuning and everything else. And then and also speaker systems. The speaker systems were amazing on these things. In fact, those speakers were so good that a lot of these old radios have been cannibalized because people take out those speakers to use them as full-range drivers for full-range speaker systems, which is a real shame. But just below the Freiburg, you had the Meersburg, and the Meersburg were very, very high as well, but they were just a little bit toned down from the Freiburg standard. And you could see that if you look for the 1958 model, for example, you'd see the Freiburg 8, the Meersburg 8. You'll see the price difference when they were launched. The original price, market price when they were launched, it's quite a bit lower. And then below that, what did you have? You had the Villingen, you had the Freudenstadt, you had there was another one or two, I forget. But there was a very clear classification of value. And this particular one, this radio that I'm working on, and you can see there's a skeleton. I've done some of it already. This one is it's a stereo model. It's actually the schematic for this thing describes it as the schematic for the stereo, for a particular stereo model, but also for the Freudenstadt 16. So it's already getting to that era where it's moving away from that strict quality level scaling that they used to use. But when I got this thing, as I said, I hadn't seen it close up. I saw the photos. I bought it. When I received it, I went, I wasn't even sure I was going to do it. And having opened it up, which is the content of this video, you'll see what happens. I'm glad I did. And I hope that you stick around to enjoy this series, because together I think we'll learn quite a lot, which is the whole point of my hobby. So stick around, enjoy the video. Before I carry on, I want to thank the sponsor of the video, PCBWay. You can find them on PCBWay.com. To date, I've been a user mainly of their simple two-sided PCBs. However, the range of services they offer is really comprehensive, and you can find just about anything you need for your production. They've got advanced PCBs where you can get a quote right on the channel, flex PCBs, which I've been tempted lately to look into and try. And of course, something that really interests me is the CNC machining and 3D printing that they offer as well. Again, you can get your quote directly from the channel before you order. So whatever your requirements are, go to their website and I'm sure you'll find something for your needs. This is one really weird radio. It is a Saba Stereo I model SR16. I was able to determine that from the back panel, which I've already removed. But other than that, it looks really weird. And I had to sort of do some research and I figured out why. These guys painted this thing. All the pictures I can find of the Stereo I SR16, this thing's in wood. There's some labels down below on this, practically on this level here, telling you what the switches and the knobs are for. This thing's got nothing. It's just black. They've painted it a piano black and they seem to have done a fairly good job of it. But I'm convinced this thing was, yep, I can see, well, I can't see white. I don't know what the hell I'm seeing here. But the point is, when I got this radio, I looked around for a black version, couldn't find it. Perhaps you can inform me otherwise. But it really is kind of strange. However, why did I get this guy? Well, it is stereo. More importantly, it's a Saba. Now, I love Sabas. I am prejudiced in favor of Sabas. But this was 1965-66. So this is the first Saba that I've worked on that's actually a few years younger than I. So I can judge it from my pedestal of a wiser old person, which I couldn't do with the other models. We'll see how this one comes out. It seems that when Saba decided to do this, they decided to change everything. Everything that was conventional, they decided to flip on its head and create this. I won't call it a monstrosity yet because it hasn't grown on me, but I want to give it a bit of a chance. These switches here, I have no idea what they are because there's no labeling, but I can obviously find that out quite easily from the service manual and any other photos and stuff that I can get on the web. But they are a dull, I don't even know what they are. It's plastic. I believe it's plastic, but there's like a paint layer on it. I'm not sure if it's dust or paint. I'll find that out when we get to it. But this, I think this one is on off. And then this would be long wave, medium wave, short wave. I'm missing something. Never mind. And then these guys, this will be probably, one of these could be a balance control. One of these could be a tone control. Now this will probably be balance because there's one of these things in the middle. And then there's individual tuning. Now I can see this red dot corresponds to the red needle at the top. So this will be, oh, it's broken. It should have come down here. This will be the AM tuning. But that is broken, that pointer. And this is the green pointer for FM, which seems to be intact. It goes as high as 104, which means it's already a little bit more modern. And then we've got this thing here, which is the antenna rotator. And they really have gone to town, haven't they? They really did go to town getting this antenna rotator to become an integral part of the dial. I don't know how important this would be. I suppose if you listen primarily to AM stations, you would want to know which way to rotate this so that you can get the best reception. A lot of the others, in fact, I think all these Sabas have got that incorporated usually into the volume knob. Little obvious here, but what else do we have? We have the magic eye over here, and we also seem to have a stereo indicator light over there, which I've never seen on these before because this is the first time I'm working on a stereo version. Let's look at the back. Well, the back seems to be pure Saba. When I say pure Saba, I mean pretty complex, pretty dense. It looks like pretty good quality, as you'd expect from Saba at this stage. But things are very, very different. For a start, this radio does not have speakers. It's got 3 outputs for external speakers. No problem there. Then we've got some pretty hefty components over here on a PC board, or 2 PC boards. Now that is definitely a first for me on Saba as well. First of all, we've got a hefty transformer, as usual. Really big dual filter caps over here on the side, which I can just see through there. That is not unusual. It's actually quite easily accessible. I think this whole thing will come out of the chassis, so it should be quite easy. We've got what looks like the FM front end over here. I think that's the FM tube. There's another couple of tubes here, a couple of IF transformers. I'll have to check the schematic to figure out what that is. That again, not unusual in itself. This is the part that I never worked on before. That's the stereo decoder for FM stereo, and we've got the output section. This thing uses two output tubes, two ECLL 800s. I really pray that they're in good shape, because these guys are expensive. And what they are, let me keep this out for now. They're actually dual pentodes. I think they're like two EL95s, if I'm not mistaken, but in one envelope, one tube. And what this does is it allows you to use a single tube in push-pull. So the tube having two output tubes inside it would allow you to drive the output transformers in push-pull instead of single-ended. And those transformers are here. Two transformers feeding the speakers. These transformers look quite hefty. The quality on this thing should be pretty good. The sound quality here should be pretty good. But I guess we'll find out. As I said, I'm pretty nervous about that tube, because if one of those output tubes is blown or weak, it's going to cost me a pretty penny, especially with the state of the tube market these days. But again, this thing is on a PC board, which I had never seen on a Saba before. You have to be very careful with these boards because they can be pretty fragile. I see they've gone for what look like film capacitors rather than the paper caps. So I think the usual problem of really poor condition paper caps is not something we're going to run into here. Some pretty hefty pots there. Those would be dual pots for everything, because this thing is stereo. Okay, so the next thing I need to do is just get this thing out of the cabinet and see what we're looking at. It should be pretty simple. I think it'll be simply a matter of removing some of the screws on the bottom. This whole thing should come out. Hopefully that whole faceplate assembly will come out with it, because it is pretty big. And I hope I don't have to desolder anything. Usually what you need to desolder here are the speaker connections. You don't have speakers here. So let's see if I can get this out without any drama. That was actually very easy. I took the knobs off as expected. 4 screws underneath. This thing just flipped back. And we start seeing, I'm starting to like more of what I see, because that black cabinet really put me off. It really did for a while. But this looks in pretty good shape. The glass is in perfect condition. All the writing there is visible, not chipping off, not peeling off. So far so good. Let's look at the back. Big hefty transformer over here. 2 filter capacitors. This has got a lid that clips in here, but it's come off, so I'll just take it off. Put it aside. That means we've got, oh, this is brilliant. We've got easy access. Yeah, these guys are very easily accessible. You can unscrew them, restuff them, do whatever needs doing. We've got good access to the back. That thing there is a rectifier. That's a different type of rectifier to what I'm used to. That will probably be some kind of death cap. One of those filter caps across the, either across the mains or across the secondary of the transformer. It's a 1000-volt cap, so yep, they expected some action over there. There's a fuse here. This is the magic eye over here, and the magic eye is different because I can see a little hole at the front that says stereo, so it obviously indicates a stereo light. I don't know what magic eye they've got on here, and I don't know what kind of magic eye would give you a separate stereo light, unless they've got a little incandescent lamp there, but we'll find out as we go along. All this mess over here is to be expected. There's some switching going on here with the antenna selector. The ferrite antenna, I'm going to turn that knob on the front, and you can see that turns the direction of the antenna. It needs a bit of cleaning, obviously, but there is a position here where the antenna actually switches out. See, these switches over here actually switch the ferrite antenna in and out of circuit. If I go around, let me try this. If I go around there, it gets to a point. I can't get this moving properly, but it gets to a point where, there we go, boom. See that? I'll do that manually. This thing switches back and it disconnects that one, makes that one. So you see you've got these guys that are activated by a little knob on the little protrusion on that base of the ferrite antenna, which allows you to switch to one end. If you want to use the internal antenna, the ferrite, this is obviously for AM. You rotate it to the angle you want, wherever you want, wherever your station is located. And then if you want to use the external antenna, you go all the way to the end and boom, it clicks out. And it works very well. All the other Sabas have got that as well. Okay, here we got the front end. No, actually, not even sure which end this is because the front end is over there. These are the IF transformers, probably the IF amplifier. But here they've got a socket. And the first thing you'd think is that there's a tube missing, but I don't think so. I think this is one of those test jig socket that Sabas use to align the radios. They would have had a test jig that they use to do the IF alignment, RF alignment, and everything else. And you can use that as well. For example, when you want to align the IF, they tell you to cut the effect of the AGC by feeding a minus 4.5 volts into one of these pins. I can see the tuning condenser on there. Tuning condenser, this will be for the AM. Let's see if it's turning. As is the indicator. As I mentioned, the indicator seems to be broken, but at least the dial strings seem to be in place, which is a relief. We've got our pots over here. One of these will be volume, probably that one, because there's a dual pot. The others also dual pots, it seems. They're all turning. So again, audio stage probably. And as I mentioned earlier, the good news is that these capacitors, these guys here, these would normally be the paper caps in the old versions. These seem to be film caps. I'm hoping that they're in better shape than what those paper caps would have been on this radio. Power amp stage with the two dual pentode tubes. I've used this tube before. I've been fortunate. Every time I've had one of these, they've been in good shape. I'm hoping this is the same. The same happens here. That'll be a driver. Not sure what tube that is. I'll have to just check the schematic, which I do have, by the way. This is the one I've removed. And just so that I don't tempt fate, I'm going to remove that as well. Keep it safe. What is this one? ECC83, a good old 12AX7. Okay, no mystery there. Right. Here are the two output transformers. They seem to be identical. This connector here, I would imagine, is a third speaker or a separate speaker output. It's connecting to the two of those. I'll have to check the schematic. There's a strange speaker output system on here. And I think you've got the option of connecting it over here, or you just plug it in there and get your stereo speaker system coming out. I'll have to check that because obviously I need to rig this so that I can test it. I don't want to test these guys without a speaker connected. I don't want to damage those tubes or the output transformers. Okay, well let me look at the part that's the mystery to me. This stereo decoder, which I've never worked on before, has its own adjustments. This would be to adjust the signal detector, pilot tone, and so on. But I'm sure that the instructions will be quite clear. These instructions for the Sabas were very complete. Originally, a lot of the ones I did had the instructions only in German, but I believe they've got an English version for this one as well. It was later. There was a lot more export going on. So obviously they accommodated that. What are the tubes on here? I haven't even really checked. What is that guy? EAF 801. Not one that I have on hand all the time, so let's keep it safe. That guy. I'm looking for the run-of-the-mill, yes, ECH 81, okay. I've got those. Got the FM tube over here, which is a bummer to get out. How the hell do you get this out? There's this in the way, isn't it? Well, no, I've got it. ECC 85, or is it 80? Looks like 85. I hope it's an 85. I've got some on the way. I ordered from 3 different places, and now they tell me they're all sending them at the same time, which is fine. Okay, lots of mechanics going on here. Saba always loved their pulleys, and this is no exception, although obviously this is a little bit stiff, tied up. But there's a lot of pulleys going on here for the dial cord, for the antenna direction control. Oi, this is going to be fun. But at least I think this has been restrung. This looks like it's new. So at least some of these have been restrung. I'm hoping they're strong enough to withstand some of my messing around with them. This is different. Yep, definitely been restrung. They've kept some of the old cord and they've used some of the new cord. I'm going to get this thing onto my contraption, make it safer to flip it around, and then we'll be able to look at the underside and start planning the way forward. This one's pretty big, so I need the big contraption. We're going to start off today in a part of the bench that I don't normally film. This is my Variac, this is my dim bulb tester. I've got the multimeter, Big Brother, measuring the B+ right at the first filter capacitor. And what I'm going to do is I'm going to switch it on low voltage and see if our transformer is working. Now remember, all the tubes are out except the magic eye, but that's not a problem. And we're going to start very low and see how we get along. I've put this on one light bulb. All the others are off, so only one light bulb. So there's a very, very strong limit of 40 watts. It's off, it's on limit. I'm putting it on. At the moment, we are getting, this is very inaccurate at low voltages, but we're already seeing some voltage on there. Okay, that's a good sign. Let me go up a bit. I'm up to 80 volts. Our voltage here is 230, 240, so we're at a third. 100 volts. It's going up nicely, and nothing's popping. I'm watching this over there. Let's go to 150. So we're at about 200 volt B+, but I'm not taking it any further because all I wanted to know is if the transformer is fine, and it seems to be. The other thing I know is that the heater voltage, the heater supply is working because the dial lamps are working, both sides. We can see the one here, there's one on the other side. So our 6.3 volts, it's probably not 6.3 volts right now, but at least that is fine. The other thing is that the capacitor grounds are not connected to the chassis. The chassis is actually at a lower potential, and I believe this is to create some bias level. I'll show you that on the schematic. I think there's a difference of about 10 volts between the capacitor grounds and the actual chassis ground. Let me show you on the schematic what I'm talking about. This is what we're looking at over here. We've got the mains coming in over here, and it goes through a switch which is non-existent at the moment. I'm going to have to replace that. They've wired this directly through to the transformer. It's set to the 220 volt option. And then we've got two outputs over here. We've got this over here, and we know this is working because our dial lamps are working, which means our 6.3 amp fuse, which I haven't actually seen. I saw the one fuse, not this one. But these dial lamps, both dial lamps are working, which means we can do this. So if we want to start painting, we can paint that. We know that's working. The other thing we know is that this over here is working. It's coming out of the secondary to the rectifier, which is, I'm not sure if this is a silicon or a selenium rectifier. I think it's selenium, but it's a strange format. I haven't seen that before. What we've got here is we've got our AC coming out of the transformer to the bridge rectifier. We know that the positive is coming out of here, the B+, and it's going to this first filter capacitor, which is where I measured it. And we also know that this negative is actually going to the bottom of the capacitors, but it goes through a 100 ohm resistor, this one over here, and then it goes to chassis ground. So our negative of the capacitors, which is usually where our ground is not at ground at the moment. And this is something which is a little bit odd, but here's the reason. If we go to the negative of the capacitors, it is at 0 volts from the supply, but it is not at chassis ground. It's actually at minus 10 volts or minus 11 volts relative to chassis ground if you take it from there. Okay, and the reason for that is that this is 0 volts over here, and because current is flowing into there through the whole circuit back into there to the ground of the capacitors, this is at a lower potential than the actual chassis. So that's where we get our minus 10 volts. And if we follow that up here, I'm sure it'll go to the bias circuits. I won't worry too much about that. All I wanted to know is if our transformer is good. And it seems to be. Now, from here, I don't know what it's like. I know the switch is dead. There is no switch, but I do know that this part of the circuit is perfectly fine. So far, anyway. This guy here, I'm going to be buying a new safety cap tomorrow, 22 nanofarads. This is the one I mentioned. It's a 1000 volt cap, pretty high. I might put two 47 nanofarad safety caps in series. That'll give me a higher voltage rating. I'm still thinking about that. But we can see here, we should expect about 270 volts, B+. This is relative to ground, of course, not to the bottom of the cap. But I didn't want to extend it that far because I don't know what these caps are like. I don't know what that one's like. Quite frankly, I don't have a clue what the condition is of some of these components on here, how long this thing's been off. So that's all I'm going to do here. Now, what I'm going to do next is test the output transformers, and this gets interesting. What I want to do is I want to test these output transformers. I want to make sure they're fine, and I don't want to do it powered up. And there's a very easy way to do that. I've got my workshop speaker over here. This is the one with the dummy load incorporated, but I've got it on speaker. Here's my plug. I'm going to plug it into what I believe is the left. I think this is left, right, and this is a surround type speaker, but I think this is the left. Doesn't matter. We're going to do both of them. And then what I've got is I've got my signal generator producing a 1 kilohertz tone at 1 volts RMS. And now what I'm going to do is connect the signal generator signal ground to ground. And with the signal, I'm going to touch the pins of the output tube. I'm going to touch the pins corresponding to the anodes of the output tube. I'll show you on the schematic what I'm doing. And I know it's 3 and 8, so 1, 2, 3, nothing. Maybe it's this one. 1, 2, 3. Yeah. Can you hear that? That's one of the anodes of one of the pentodes in that tube, and 8 is the other one. Brilliant. One of those transformers is fine. Let me try, put the speaker on the other side now. And we'll go to the other tube. Pin 3, 1, 2, 3. Yes, and pin 8. Yes. Well, our output transformers seem to be okay. This is not an absolute guarantee that they're fine, but it's a good indication. And this is important because the transformers are probably the most important parts of this whole set. Between the output transformers over there and the power transformer over here, you've got 3 of the main components that determine whether a restoration is going to be viable or not. If any of those are gone, you've got a problem. And there's something else I want to tell you about these speaker connectors. They were very interesting. Speaker connectors like these DIN connectors normally have 2 holes. There's a typical case, ground and signal. This thing's got an extra one, and this is actually a switch. This thing, when you plug in the correct type of speaker plug, which would be expected for this kind of radio, it would have a prong sticking out here, which would go into that hole as well. So your signal would be here, your ground would be here, and that prong would actually open a contact behind on the inside of this socket, which disconnects the speaker signal from going somewhere else. And that's important because we can actually see that on the schematic. The part of the schematic that's of interest to us now is this over here. This is our dual pentode triode tube, one of them there, one of them there. That's pushing the one side transformer. This one is driving the other transformer. What we've done is we've connected the speaker between this point and that point. So the secondary, this has a feedback winding as well that comes back to the feedback circuit. But the one that's actually driving the speaker is this secondary over here. And our transformer is in push-pull, so it has two half primaries. The B plus comes in here, and then this primary is driven by that anode, and this one here is driven by that anode there. So this is push-pull. It's a typical push-pull system, except using one tube that has the two driver tubes inside. And what I did was I put a signal over here. Remember, the tube was out, so I put a signal over here. And this signal is going in there, through that guy there. Now, I connected the other side of the signal to ground. How does that work? Well, it comes out here to pin point 2 over here, and 2 is part of the power supply. So it's basically coming to here. And what happens here? Well, this gets to this point, and it meets this bloody massive capacitor, which is just a short circuit to ground. Then, of course, there's a 100 ohm resistor through here. So that's where it meets ground over here. It's actually going over here through the whole power supply to meet ground. That's why our signal gets through to that primary. And then because our transformer is good, the signal is being induced on this secondary, which then goes to the speaker. And of course, when I put it on this anode as well, it does the same thing on that half of that primary, and it goes through to the speaker as well. And this point, left K, this one here is right signal K. Okay, this is the other channel. They go to the speaker network, and this is speaker network over here. There's our left K, right K. If we take the left, it comes in here. It can drive a separate, an extra external speaker in parallel with all the others, but then the signal comes in here. And if you look at that, there's actually a little plug over there. Can you see that? That connection is being made. So effectively our signal's coming in here. It's getting made to there. And it would go to that point over there, right? However, if we have this speaker plugged in with the correct plug, which I do not have, then the signal does this. It comes out here, it comes to here. It doesn't go out there, it doesn't go down here. It can only come out this way, which means it'll go to my speaker. And that's how we get that signal on the left and on the right. And then, of course, there's this system here as well, so that when you do not have this speaker connected, this left signal comes in here through that switch to this thing over here. And likewise on this side through that switch, which is made, remember, because you don't have a plug here, and it goes to pin 1 over here, and pin 2 is ground. And this, I believe, is that little socket, the green socket on the side that I showed you, which would go to, this is if you have a Freudenstadt 16. Remember, this circuit is for 2 or more models. One of them is the Stereo 1, and the other model is the Freudenstadt 16, which has got it's got built-in speakers. So that's what you would connect this speaker arrangement to. And all they've got here is they've got the common ground, and they've got a mid-range speaker, you know, the normal speaker over here. Then there's a capacitor, and you would have a tweeter, you know, higher frequencies for the left channel and for the right channel. Nothing complicated there. So we know our transformers are good, which is a good sign, and it means we can carry on with the project. Well, I've now established that the transformers are fine, but I still don't know whether this thing's going to work. So what I'm going to do is I'm going to power it up. I'm going to do it carefully. I'm going to do it with a lower voltage than the normal supply. I'll probably put it at about 150 volts first, and then, yeah, I'll see what happens. I've got both speakers connected at the back to the sockets that I know are the correct ones for the speakers. I've got my mini whip connected to the antenna socket at the back. I'll be using the external antenna. I'll put the volume up. Let's just check again. This is the FM tuning. This is the AM tuning. This is the volume. So I'll put the volume on max. This is the balance. I'll put that in the middle. It's got an indent there, so you know when it's in the middle. This is power on, which is not working. And this, I believe, is long wave. It'll be long wave, medium wave, short wave, FM, phono, and stereo. So we leave it like that. I'm going to move to the dim bulb and the variac and power it up. Let's put this at 150 volts or so and power it up. See if we hear anything. We don't see any smoke, which is a good sign. Can't hear anything yet. Nothing at all. Our magic eye is working. Oh, I can hear some hum. What happens if I push stereo? That's the stereo switch. Doesn't do anything. Obviously stereo won't work with AM, but I'm hearing some hum. Yep. No, it's this one here. That's long wave. Let's try medium wave. Nothing. I'm going to put the voltage up a bit more. In fact, because I've got the dim bulb tester in place, I'm going to put this up to 230 volts. Okay, 230 volts with the dim bulb in place, so we still have some restriction. That end is getting louder. And it goes down again. No, shortwave. Huh. Picking up something there. Okay, we got something on shortwave. Brilliant. Strange that we got nothing on medium wave. That should be the loudest one. What about long wave? Ah, got long wave. Let's try FM. I don't expect anything on FM, but hey. Ah. I'm getting a weak signal on the FM. I've just got to change the antenna around here because it's FM has basically got no antenna at the moment. Bloody hell. That is the mini whip antenna. I've just plugged it into the FM antenna socket. I'm not getting anything where I expect two stations down here, but that's not important. The important thing is we've got some reception. I think this thing is shifted. You see, I normally have a station on 88, another one at 89.3, very strong stations. I've got a feeling that's my 89.3 down here. coming up at 96. I think my dial has shifted. It's an easy way to find out. It's on 95 at the moment. So I'm going to try this. This is my ELV FM signal generator. Try this at 95. Let's just increase the power a bit. Put it at maximum power. There's a station on, let's try 96. Should be getting a tone. Well, let's leave it at 98. I'm assuming this thing is picking up much, much higher. Let's go down. Yeah, exactly what I thought. So 90 is picking up at 98. So my whole FM dial is completely shifted. So this should be quite a bit of fun trying to align this, because it's quite a big shift. But the good news is that this thing's working and I can't switch it off because it's got no switch. So let me put that off at the dim bulb tester. Now the first thing I wanted to repair is actually the on-off switch. And if I push that down here, that pulley goes back. So there's nothing on this side, nothing in there that indicates what kind of switch it was. But in the meantime, I had an idea. This is all I'm getting from on-off. There's no latching, which is fine. You can push on, push off. And let me show you what I got. I got me one of these switches. This is the pull-on, pull-off switches that you use in some reading lamps. You just pull on, pull off. And now what I'm going to try and do is fit this in there so this thing is tied to that pulley. So when I pull it, it comes on. When I pull it again, it comes off. Now, it's pretty stiff. I don't know if that's got enough strength for it, but I'm going to try and adapt it. You see, it's just one make and break, which means I won't be able to switch off both the live and the neutral. I'm going to choose one of them. I think the schematic calls for a dual pole on-off switch, which means you can actually disconnect mains completely. I'm not sure this is going to work. This is pretty stiff. It works, but it's very stiff. There's a hole through the middle there that I can use to connect this to the chassis. I think this thing just comes off so that you can get access to the screws on there, to the terminal pins. I'm going to work on this a bit and see what I can achieve. I'll let you know in a second or two. Okay, what did I need to do? I started off telling you that I'll see you in a few seconds. I was playing with the magic of YouTube. You know, you film, you cut, you come back. But this has taken so long, I've got to explain what I had to do to get in here. I put a switch in there, but let me show you what I had to do first. In order to get there, I had to remove this front. Now, obviously, I wanted to take the faceplate off the glass. I don't want to break it. So the first thing I did is I loosened these two guys, lifted them up, lifted them out, in fact, and then the glass came off and I put it away. Now, what I've got into a habit of doing is I put these brackets back with the screws. Once I've removed what I need to remove, it makes life a hell of a lot easier when you want to, you know, find the screws that go into the particular places later. Then I had to take that plate that's over here, and for that I had to remove a little fishing line that goes along here, which holds the dial, the bottom dial. I think it's just the bottom dial, the FM dial. That's just a spring on here. You just pull it out, no problem. You can see it. But then I had to remove some more screws to bring this section out, which is the faceplate on there, the one that's behind the dial glass. And that required 1, 2, 3, 4 under here, plus another 2, plus this one, plus that one. And it all comes out and it slides through these or past these knobs or extender, whatever you want to call them. So this whole thing comes out, and then you got good access, and that's great because you need it. And it's a good thing that I've got all this out anyway, because I'm going to have to restore that plate, that dial. I need to check some of the dial strings here. Some of them are getting stuck. Anyway, I needed to get access. Also, cleaning becomes a hell of a lot easier when you've got the front off. Oh, there's something else I can see here. See the things you discover? These things have got all these little hidden functions. You see that? When you are there, that switch is open. When you do that, it closes. I'm not sure what this does, but I'm sure it's a function that's described. I need to check that. These things are usually hidden with, or have a whole lot of little secret switches hidden all over the place. I'm quite familiar with the Saba trick of doing that. The Freiburg 8 had a lot of them. Anyway, let's go back to the story. So once I had access, I had to figure out how to do this, and I've got that switch in here. I found 2 holes on this bracket at the back here, and the screws I've got here fit there perfectly. I think they're M3 or so. And what I did is I extended the wire coming from the mains. You have to loosen a little tightener that they have down here, just to give it a bit more length. And then what I did is I took one of them to one side of the switch. I had replaced that yellow wire that goes to the fuse section at the back there. It goes through a transparent shield or screen over here. That's the other side of the switch. And then these two, this side and the other yellow one, I just soldered them neatly, put some heat shrink on. And now I've got a closed, or I've got a switch section. Then this cord, you can't see it, can you? I suppose you can. This cord down here goes through that little pulley and it switches on and off. And how do I know that? Well, I've got my multimeter connected to one leg of the plug and the other one to the input of the socket. And watch this, listen to this. On, off, on, off. If it wasn't so irritating, I'd sit here doing this all day because I'm so chuffed. I actually think the switch they had here was probably fairly similar to this one. I would imagine that's what they've got. I don't know. The point is, that's the best I can do, and it's doing a perfect job, with the exception of this second mains line, which is not switched. And as you probably know, most of these radios don't have dual switch lines, so this is no big deal. But now we've got our mains switch on, and I don't have to switch it on at the dim bulb tester. Good. What's next? Well, we know this thing works, so checking the power supply per se is not a crucial requirement. We know it's getting there, but I need to check things that make sure that the voltages are correct and they're getting to the right places and that the resistors are within tolerance. And more especially the capacitors that I do need to change, I need to change them. And I know for a fact that these guys are going to have to go. Now remember, these things are not, these are not connected to the chassis. Remember what I said about, on the schematic, what I said about the grounds of the capacitors not being connected to chassis? Well, here's the proof of that. There's an insulator between the metal can and the chassis, and then the ground is taken from here. Normally, you would just have the shield or the case of the capacitors connected straight to the chassis, which is ground in this case. So we've got to be careful with that. I'll be replacing these 2 caps, probably restuffing them. There is actually 4 caps. 1, 2, 3, 4. This one might even have 3. So 2 in each. I think this one might even have 3. But I'll be able to see it when I remove these guys. I'll be restuffing these caps, get the power supply nice and clean. I'll check what's happening with that selenium rectifier. I think it's a selenium rectifier. I'm not even sure about that. But this is the first time I've seen this style rectifier before. It's the usual story, you know, mains in, mains out. Rather mains in and plus and minus out. No surprise there, but it is rather different. In fact, there's something strange here. There's ground, mains. Okay. I think these are both ground outs. I'll have to check. I'm not sure that I need to replace it. It actually looks like someone has soldered on there. There's been new solder put on here. So somebody's messed with that. I'll have to check it out. I need to go over this carefully. A lot of these resistors over here are the ones that, you know, they heat up quite a bit. They're the more powerful resistors. You've got to check them. Make sure they're within spec. If they're not, just replace them and get the supply ready for the next stage. The next stage, of course, being the audio section, which we know is working, but we need to make sure that it's optimized. And the way I'm going to do that is check the audio section, and then I'll be able to feed a external signal on here. This radio is a great candidate for the Bluetooth modules that I use, because the audio quality is going to be bloody nice on this. I know it. With those two output transformers, the size they've got, the quality Saba used to put into these things. Now, I do know that this is not quite at the level of the some of the Freibergs. I think this is probably at the point where, unfortunately, some cost cutting was happening. The fact that you got a PC board obviously makes things a lot cheaper. I don't know what it did to reliability. I don't know what quality boards they were using. So I'm not going to pronounce myself too soon on that. The point is, we should get a good audio signal out of there. Stereo, which is great. And that's it. That's what I'm going to do. I'm going to follow my usual routine, which is power supply, then the audio stage, then the AM section, then the FM section. And so this is where I'm going to cut this video off for now. I've got a lot of work to do on especially on the capacitors. I like to do them by restuffing them, but it's a lot of work. And I like to do that calmly, not stressed. I'm not going to rush the restoration just to get that thing done. So I'm going to leave you for now. I'm going to thank you for your company. I hope you've enjoyed this and stick around for the rest of the series. This Saba should be a great result. I don't know what the chassis, what the cabinet's going to look like. I can still not quite look at that black cabinet without cringing, but we'll see what ideas I have, or maybe what you have. Put them down in the comments below what I should do about that. And if you know anything about a mysterious black cabinet stereo one, let me know, because I certainly can't find it. Anyway, enough for now. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or on PayPal. Links on the description below. Thanks for watching. Bye for now, and stay safe.